Hello, and welcome to another Precision Flyer Repairs video. This one is on a custom-made American Flyer Circus 353 steam engine, which you can see is in a different wheel configuration than the original Gilbert. This is a 482, a customized engine that was given to me by a customer because they weren't happy with the way it was running. And it's a unique engine. I thought I'd share it with you. I'd also thought it might help for me to share with you some of the work that was required to get it to run. And then I'll run it and let you see how it performs today. The first thing that I wanted to point out is this obviously has a custom shell that was made so that it's extended and much longer than normal. It also has a custom-made chassis. That's not a northern chassis from Gilbert. It's not your standard 8-wheel or 4-axle steam engine chassis from Gilbert. The builder endeavored to actually put 3 different chassis pieces together to come up with their own unique 4-axle or 8-wheel chassis. It's a little longer in wheelbase than a standard American Flyer Northern. So it's potentially challenged a little bit with standard radius curves and switches, but so far not so much on my layout, which only has 20-inch radius curves in the switch sections and elsewhere larger than that. But I thought it was curious and interesting that they endeavored to make their own chassis out of 3 different segments from other chassis rather than use a standard American Flyer Gilbert Northern chassis. And it also has a LED headlight instead of the incandescent bulb. It has a can motor rather than the Gilbert open frame motor. And you can see that this has a 2-wheel trailing truck, not a 4-wheel. The 4-wheel is what originally came with it, but it couldn't clear all of this fillet work here underneath the cab and the ladders. And the owner and I thought it would be a terrible shame to have to mill that away in order just for the trailing truck to clear. So this Delta style from the K5s and 293s and others really fits in there pretty nice and looks great. It makes it a mountain class. I think it may have also been referred to by some railroads as an Ozark class, depending on the railroad. And as you can see then, it has a Hudson American Flyer tender. And in the tender was an electronic reverse unit. So can motor, electronic reverse unit, custom-made chassis, custom-made shell, LED headlight. So where were the issues? The issues were that it didn't run. And the largest problem was that all of these drive wheels were put together originally using reproduction, shiny, new metal rims. And there's nothing wrong with that. But the problem was they were put together in less than a precision fashion. In fact, 5 of the 8 were wobbly or diagonal or off true, if you will, enough that their edges contacted the chassis. So you can clearly understand the 5 out of 8 would mean there's even more than one on probably both sides, and there were, which would create a direct short, given that the rims that touch the frame and touch the rail are hot. So all 8 drive wheels had to be removed and disassembled into their 3 components and reassembled using wheel cups and an arbor press to really get them made the way they ought to be assembled, and then put onto the axles, put onto the frame, quartered correctly, gauged correctly, and made true to run as straight as possible. And at this point, I thought I'd use a few props to maybe help you understand what I'm talking about. Here's a rim. This is actually an aftermarket reproduction rim like what were used on this train. And here is an insulator. This is the white insulator that goes inside the rim like that. And then you affix it so that it's a good, tight, and steady fit. And then this is the hub that goes inside those 2 components. And then the axle is what goes into the back of the hub, and that then goes into the frame, and the other side joined to it with the proper quartering gun. What's happening on a lot of American Flyer from the 40s, 50s, and 60s is these three components of a drive wheel are just coming apart because they were just press fitted together at the factory, and the hubs are coming loose on the axles. In the case of this engine, the new components were all put together, but they weren't put together with the alignment that they should have had. And so the train would short out against the chassis and not run, and even if it had a chance of running, would have been pretty badly wobbly down the tracks. So those 8 were all taken apart into their 3 components, which means 24 individual parts, and then all 8 were remounted back onto their axles and quartered with their partners. Now the assembly process is really important, because what you want to do is you want to get a good sound fit of the 3 parts, and you want to get a proper alignment. The insulator should be flush with the edge of the rim, and the hub needs to be pressed in deep enough that you see a little bit of it sticking out the bottom. That keeps the rim away from the frame or the chassis of the engine, and yet not too much so that the offset for the connecting and side rods is underneath the edge or top surface of the insulator. So you really have to be careful. You want the hub in deep enough but not too deep, and you want everything nice, flat, true, and level so that you get it on the frame, it's going to run nice and straight for you and help the train be as smooth running as possible. So that was a big chunk of work. The reverse unit was wired with its leads to the motor brushes, which is fine, but then the motor brush wires were then connected up to the smoke unit, and the smoke unit had connections then up to the LED. When you use an electronic reverse unit, the leads that go to the motor brushes ought to just stop there, and direct power from the track, not through the reverse unit, fed to the smoke unit, and then it's okay to also put in line with that the headlight or the LED. So I put in a new reverse unit, Dally number 400 universal. I think they work very well, and it's wired now to the motor as it ought to be, and then separately there is power from the tracks that comes up and goes to the smoke unit and then onto the LED. The LED also needed 1000 ohm 1/2 watt resistor added to it, and a 1N4002 diode put in line so as to prevent burning out the LED. It only had a very small resistor in line originally. With the addition of the new reverse unit and the extra pair of wires, I ran the 4-wire harness that you're all familiar with that Gilbert used on many of their engines, and I custom shaped a jack panel to go in the back here under the roof of the cab. And so now this kind of has that classic Gilbert look to it, but it's really a modern electronic reverse unit in here, CAN motor, and LED headlight. The smoke unit was really in pretty good condition. Had a few loose screws when it was stripped, did some work there to shore it up better, and the unit has turned out largely to run really well. In fact, it runs so well and efficiently that I haven't been able to run it with more than 8 volts for fear of it maybe flying off the curves. With 8 volts, of course, the smoke unit isn't getting much power compared to what it would normally get between, say, 10 and 15, but it smokes with a civilized, let's say, amount of or volume of smoke at that level. So with a good amount of work to get this functional now, mechanically and electronically and electrically, I think it's quite an impressive engine, and hope that the owner of it finds it that way too and gets lots of enjoyment out of running it. I'm not going to pull it with a train simply because that drowns out the smooth running of the engine, and I thought that would be the focus of this video. And now to move on with a quick demo of it, I'm going to play back a recording that I made with my Legacy Cab 2. So if you bear with me now, the camera is going to move, and if I sound a little froggy, and that's also because I caught a cold, and forgive me for that. But doing my best through it all. Here we go, camera, like a helicopter kind of shot. And we'll just put it through some basic forward and reverse. I'm going to show you the voltmeter because of how efficiently this engine now runs. Is pretty impressive when you see what a low amount of power it takes to get it going. There we go. And she's off. And you can see the voltmeter here is reading under 5 volts. And she's chugging along pretty well down the track. Now we're speeding up a little bit. You can hear it. We're up to a whopping like 7 volts. And here she comes. And the smoke production is there, it's visible, you can see it. Now we're up to about 8 volts. And she is flying. And the smoke production, you can see it there. I can smell it. And now we're going to slow it down because it does a beautiful job of crawling. It's moving, you can see that, and it's literally doing that on 3.5 volts. 3.5 volts, and she's smooth cruising. We'll reverse it, not touching the power. So she's going to go backward now on that same 3.5 volts. That's a good sign to me that the drivetrain is free, easy, very little friction or resistance anywhere in the axles, the connecting rods, the motor, etc. Now, since the smoke unit is directly connected to the track, you can have it sit neutral and pull the power way up to maybe 15 volts and then back it down because you don't want to turn it on at that point. It'd go flying like a bullet out of a gun. But with a little power added, you can see it helps the smoke production a little bit. It's hard to see with the white road bed that I have on this track. And there she goes, really making her way around the layout. I think it runs smooth, straight, strong, and smoky, and was so glad that with some effort was able to get it working again, or maybe for the first time, to this customer to enjoy. And given that it's such a unique, customized product, I thought I'd make a quick video of it to share with you and enjoy vicariously. So until we meet again, be well and have fun running your trains.